Penguins are like the bird version of whales and seals, evolving to be at home in the water despite coming from a group of land animals. Only they evolved to colonize the oceans even sooner, and are able to dive deeper, hold their breath for longer, and sometimes even swim faster than many marine mammals. They first appeared just after the extinction of the non-avian dinosaurs, quickly diversifying and dominating the southern hemisphere, while being one of the only land animals found in Antarctica. No other land animals live here throughout the winter, and as such penguins may have a good claim of being the occupant of one of the harshest environments by any multiple-celled organism. There are believed to have been 3 different lineages of birds that survived the KT extinction that killed off the dinosaurs, that together make up all the birds alive today. These are the paleonaths, that contain the large flightless birds like ostriches and emus. Fowl, which are of course birds like chickens and ducks, their scientific name being Galloneceras, and neoaves that contain basically every other bird, from birds of prey to blue tits. It would seem that penguins were maybe closely related to waterfowl due to their aquatic adaptations, but waterfowl are considerably older and have an aquatic ancestry dating back to and living alongside the dinosaurs. Penguins are in fact neoaves and must have evolved these adaptations independently. However, neoaves do have their own group of at least somewhat aquatic birds that are sometimes referred to as the higher water birds, this group containing seabirds and storks. Scientists are pretty certain that penguins are also a member of the higher water birds, however this is where the certainty ends. As of now, it isn't very clear at all what the closest relation of the penguin is, and there are many different theories of where they came from. One theory is that they were closely related to a group of prehistoric birds known as Plotopterids that went extinct around 20 million years ago. These birds show remarkable similarities with penguins, and as they lived in the northern hemisphere are sometimes referred to as the northern penguins. If these birds were closely related, this would mean that penguins' closest living relatives must be birds like cormorants and pelicans. However, some recent studies have shown that the ribcage and shoulder joints of the Plotopterids differ significantly from penguins, and so perhaps aren't very closely aligned, and their similar traits may just be due to convergent evolution. Adding to this, DNA evidence has them more closely aligned with the albatross and petrels. However, exactly where penguins came from is still very much up for debate. The world's first penguin dates back very shortly after the KT extinction about 62 million years ago, a small bird called Waimanu found in New Zealand, and it is believed that New Zealand is the ancestral home to the penguins. Waimanu didn't really look like a penguin and probably had a body shape better resembling that of a loon. Despite being a very early species of penguin, it was already flightless with small and stubby wings and was probably quite good at swimming. Why penguins lost the ability to fly is somewhat puzzling, as it is difficult to see the advantage of this move, and there must be many occasions where a penguin could have escaped the jaws of a leopard seal by flapping their wings to safety. The theory behind the loss of their flight is quite simple and well evidenced. It seems that as penguins' flippers started to become more and more specialised for swimming, they became worse and worse for flying. Penguins' flippers are homologous to the wings of other birds, possessing the same amount of bones, although they are very different in terms of function. In fact, they are in reverse. A flying bird's wings push air underneath them to create lift, and a penguin's flippers push water above them. The mechanism that keeps birds in the air is the same mechanism that keeps penguins underwater, and consequently a good flipper is most likely going to make for a terrible wing. Penguins are fantastic swimmers, and an emperor penguin is able to hold their breath for 20 minutes and dive to depths approaching 500 meters, beating the diving depth record of dolphins by a large margin. Due to being great swimmers, they were able to increase their foraging range while hunting for fish, and this greater opportunity to get food must have been a decent trade-off for being slightly more vulnerable to predation. Penguins were quicker to adapt and take to the oceans than marine mammals were. Because of this, it is very possible that they may have taken advantage of some of the empty niches left over by the extinct marine reptiles that occupied the oceans at the same time as the dinosaurs, perhaps taking on a similar oceanic role of some of the smaller ones. Very soon after their evolution, penguins could be found around Antarctica, where their ongoing relationship with the fisheries in this part of the world would continue to this day, as the majority of them still live here. Their reason for living in Antarctica may be attributed to a few things. Penguins probably evolved far in the south because the highest diversity of seabirds existed near the poles, and due to this, speciation was more refined, leading to the extreme niche of penguins we have today. Penguins are also just very well adapted to living in cold environments, and dealing with the extreme conditions is worth the benefit of having a lack of land predators and an almost exclusive monopoly on fishing. By about 42 million years ago, there were a few penguins that found their way to Peru, which was the first evidence of these birds in South America, and showed that by this time they had already spread throughout the southern hemisphere. Puffins share many similar adaptations to penguins. They have similar colours and also have small wings that make them strong swimmers. The one big difference being that they can fly, but they seem to be the closest thing to a northern penguin equivalent. It is possible that why the penguins never colonised the northern hemisphere and why there are no similar flightless birds in the north is that they would have been easy prey for the higher number and diversity of carnivorous mammals. As penguins lay their eggs on the ground and are slow moving while on land, they would potentially be an easy meal for any wandering wolf. In New Zealand and Antarctica there are no large land predators to threaten them, and in the southern part of South America there are a few but not many, and in fact the most northerly penguin alive today is the Galapagos penguin, the Galapagos Islands being one of the only places in that latitude that has no mammalian carnivores larger than a bat. 37 million years ago, unlike the primitive penguins that came before it, one of these South American birds called Incayacu actually looked like a modern penguin, despite maybe the odd primitive feature. If you travelled back to this period, this creature was probably instantly recognisable as a penguin. One of the penguins that lived in Peru was called Icodiptes, that unlike any penguin today had a very long beak, a bit like a heron. However, the most striking thing about this penguin was that it was massive, maybe growing as tall as 1.5 meters, much taller than any living penguin. And it wasn't even the largest, as Icodiptes was merely the third largest penguin known to have lived. Icodiptes was from a whole subfamily of giant penguins called Paleodiptinae, and although Icodiptes was at home in South America, this family is better known from New Zealand. For instance, Anthropornis, which was found in the Antarctic coast and in New Zealand, may have reached heights of 1.8 meters tall, making them the same height as a man, as well as many other large species sometimes living in the same ecosystem at the same time. This group of giant penguins first appeared around 40 million years ago and were not closely related to the modern species at all. In fact, they were quite a bit more primitive, retaining some old features like a wing joint in the middle of their flipper, a homage to their flying ancestors, and which penguins have since lost. These penguins thrived in the late Eocene and throughout the Oligocene, but started to diminish by the end of the epoch. Their extinction could have been due to climate change, or perhaps due to competition with whales, which advanced significantly in the Miocene, and seals, which took to the ocean around this time. The smaller penguins were probably able to survive because they were occupying niches too small to be filled by marine mammals. Although penguins had already made it as far as South America in the late Eocene, these birds were not closely related to any modern species, and it seems the penguins that are in that part of the world today, known as the Spheniscus penguins, containing animals like the Galapagos penguin, must have travelled there a second time. It seems that the most closely related group to the Spheniscus penguins are the Eudiptes penguins that are also adapted to warmer climates than most penguins, but mostly based on the other side of the world around New Zealand. They probably diverged from the Spheniscus penguins about 15 million years ago, but didn't develop their impressive head feathers until about 8 million years ago. However, although modern penguins remigrated northward into warmer climates, it seems they can also trace their ancestry back to the Antarctic New Zealand area, as all penguins can. It is thought that all modern penguins diverged from the old penguins maybe 40 million years ago, and then branched off into all the species we have today. Scientists call this common ancestor Penguin 1, and the closest prehistoric candidate to this creature has been classed as an Aptenodytes, which is the genus that contains the largest living penguins, the king penguin and the emperor penguin, meaning these creatures are thought to be the most basal penguins alive today. Interestingly, although they are the first modern penguins, it is the other group of Antarctic penguins known as Pygoscelis, containing birds like the chinstrap penguin, that are thought to look more like the common ancestor of modern penguins. This is because emperor and king penguins live in Antarctica all year round and rarely stray northward, and so have adapted significantly to this harsh environment. The Pygoscelis penguins, on the other hand, live on islands just north of Antarctica like the South Orkney Islands, which are probably conditions more similar to where they evolved from. So remember that these waddling and sometimes adorable birds are some of the most hardy creatures on the planet. Thank you for watching. If you enjoyed the video, consider subscribing. Also, leave a comment telling me what you want to learn about on this channel. A massive thank you goes to my patrons for their kind support, especially Karim, Fosselworth and David Vanderost.